In this video we're going to look at Jit and Lean operations. Now as you'll see, it's part 4, so there are other parts for you to look at in this series on just-in-time and lean operations. It's important you look at those videos, make your own notes and do some reading in the area as well, so you have a good set of notes from which to study and revise. Now, in this session we're going to do a few things. So let's start by talking about JIT scheduling. Schedules must be communicated inside and outside the organization. It's important that just-in-time schedules are agreed and understood inside. So precisely when work starts and when it finishes, how long it's allocated, what is the utilization of the machines and the personnel, and the commitments, the resource commitments in the coming days and weeks. That's important. It's important to be set out clearly, and sometimes a Gantt chart, for example, could be used to indicate when certain machines will be in use and the jobs they will be working on. So internally, it's clearly important that efficiency be seen as important, and the scheduling of the machines and resources and the people, the scheduling reflects the importance of this for efficiency purposes. But it should also be noted that JIT could be communicated outside of the organization, because a proper JIT system may incorporate the suppliers, let's say suppliers of raw materials. These companies may be required to deliver materials quickly to the business. They may be required to deliver them quickly, or alternatively according to some planned schedule. One way or the other, the businesses will be expected to respond. So the businesses, separate businesses supplying raw materials, let's say, these are in a sense part of the organization of the production business. So the production business does not hold stock. The stock will arrive just in time for it to be used in production. In fact, the delivery will not take place perhaps to the stores, because that will mean handling the goods twice, handling it into the stores and handling it from the stores out into the production area. So the delivery may in fact come directly into the production area. So it gets rid of that extra layer of handling, so it's more efficient. So scheduling may be communicated internally. It certainly promotes efficiency and greater clarity about the work processes that need to be carried out if it's communicated internally. But also it could be communicated externally. And with the advent of better communication systems, nowadays many companies may have access to other companies' databases, databases of, say, raw materials, and they can interrogate the database, find out what's held in stock when new deliveries are going to be made into the other company, into the supplying company, and may then place orders online and do it automatically and schedule the orders for delivery on a particular day, even at a particular time. Now, having said all of that, there are several assumptions lurking in the background. The assumptions are that the other company, the supplying company, is efficient, it can deliver on time, and even the environment is important. When the trucks leave the premises of the supplying company to deliver the products to the production company, there's an assumption that the trucks can travel there in a certain time period. There could be roadworks, there could be accidents, the machines, the lorries I should say, or the vans could break down. Various things can go wrong which could really upset the scheduling. So sometimes it may be too tight. The requirements may be too precise, and perhaps some slack, a small amount of slack, could be built into the system. Level schedules means that schedules without variation, schedules which are level, they're equal. The schedules do not vary a lot, and therefore the efficiency of the business is promoted. So with JIT scheduling, the idea is to balance the production, balance it in a way that gives continuity, and also small amounts can be produced, but produced efficiently, but in a continuous stream, and there's no variations or switching over machines necessary throughout the process. So it's a carefully thought out schedule. So the processing takes place generally in small batches. The idea there is that because they're in small batches, less raw materials have to be held in stores because it's in small batches. And the deliveries from external suppliers, say raw materials, the deliveries can be frequent. They're small deliveries, so perhaps smaller transport could be used, and they can arrive more efficiently and be delivered more efficiently. They're small deliveries. So small batch production can take place, and it runs smoothly, so there is no ups and downs or variations in the production. And sometimes when a sequence is found to work, it can be frozen. In other words, that's the sequence which will be used the next time. Precisely that, because that one works well. And if it works well, that's what can be carried over to the next time the same job is undertaken. So freezing the schedule means taking the various components of the schedule, how the sequencing of the machines and the personnel and the sequencing of the materials arriving, how all of that was worked out. Then the same pattern can be used in the future. The schedule has been frozen, and therefore in the future stability is almost assured. It's not 100% guaranteed, but it's almost guaranteed, because the same processes will be undertaken in the same sequence, the same delivery patterns, and everything will be the same. It worked before, so it'll work again. That's the assumption. It may use Kanban. These are signals used in a pull system. Now, two concepts here. One is Kanban and the other is pull system. Let's start with the pull system. The pull system means that production only takes place because customers place orders. The orders are in a sense at the end of the process. But the company produces output to fill the orders. So it's the order that's pulling the work through the company. The work is being directed towards completing the order. So it's being pulled through the company to complete the order at the final stage. So it's a pull system. We can contrast that with a push system in which managers, for example, may decide on simply making products and holding them in the stores in anticipation of future demand. Let's say the company was subject to quite considerable seasonal variations in demand. So it might want to build up a stock of products to have them ready for the seasonal peak in demand. That might be an explanation. Or they might simply want to make sure that the machines are not idle, so they're running continuously and running on large amounts of output to gain economies in production, because they're producing the same item over a longer period. The downside with the push system is all of that production is in a sense idle. It's not doing anything. Once it's produced, it's cost. It's a cost element. It's stored, and it's the raw materials, the labor, the machine time, everything is incorporated into the product, and the product is just sitting in the stores. So in a sense, it's been a big expenditure with no revenue. The company has done it in anticipation of a revenue in the future, in anticipation of demand. So that's the essence of a push system. And in the context of what we're dealing with here, Jit and Lean production, most of the concerns are with a pull system. Now the other term here is Kanban. There are separate videos on this, and you should look at those. It'll give an insight into Kanban. It's actually a very straightforward system. It simply means there's a card, and on the card will be recorded the date, the quantity of the order, the type of product that's been ordered, and that will tell the producers what to make, what item to make. And there may be different stages in the production. And this could be reflected on a Kanban board in an office, which will show the stage where the slip has got to. So it's possible for the managers to see where production has got to, and just by looking at the board. So it's quite a simple one in many respects, but it's best to see the videos that have been produced on this topic. See those directly is probably a better way forward. Better scheduling improves performance. It's certainly the case that if the scheduling is done properly, performance will be improved. There will be no waiting times, no standing around waiting for something to happen, or machines that are not prepared in advance, or they need to be switched over in the middle of some batch run. So scheduling it's better planning, and therefore better performance. Now the JIT scheduling tactics. Well, communicate schedules to suppliers. That's important, because with a just-in-time system, the suppliers must deliver the let's say the raw materials or the components. They must deliver those just in time. And as I said earlier, things can go wrong in the transport system or in the delivery system, or the company itself may not have the raw materials to make the components that are required. Lots of things can go wrong. So it's important that schedules are given to suppliers well in advance, so the suppliers are able to make provisions for timely arrivals. Now, there are issues there as well. They can't give a lot of time in advance because, of course, the customers are still waiting at the end. It's a pull system. The customers are waiting at the end, the final stage, to receive the final product. So clearly, the synchronization between the company and its suppliers must be very deep and very, very precise, so that they understand each other and they understand the importance of speedy deliveries. Make level schedules. Production smoothing, sometimes called, and it leads to more efficiency. Production smoothing, there's no ups and downs in the production. There's no variations. We don't want 20 of these and 35 of those and 2 of those. Try to even it out so there's continuity in production, and it is more efficient as a consequence. And freeze part of the schedule, as I said earlier. When the schedule is working and when it clearly has worked well, then freeze that part. In other words, capture the knowledge and capture the processes and understand them. Make notes of them and know what works and works well. Freeze that part. That part is perfect. So that can be used again, and that knowledge can be used again. And work to the schedule. Once the schedule has been set up, once it's been properly planned, make sure that the work and the whole the whole streamlining of production. Everything takes place according to the schedule. The schedule has been calculated. The schedule is how work is sequenced. And there may be some sort of queuing in the system. There might be other jobs waiting to come on. So it's important that the schedule is adhered to, and that the operators and the line managers and departmental heads, everyone knows the importance of the schedule. Try to make the work in one piece if possible, and also try to move any parts just once if possible as well. If a product has two parts, but if the two parts could be joined during the production stage, so in effect one part came off. If this was perhaps an engineering issue, and somehow during the engineering process, during the processing of metal or the processing of a component, they were able to be joined, so it becomes one piece. That makes life a lot simpler. It makes for a lot more efficiency within the business. So always try to reduce the number of components if possible. Try to integrate them. Try to reduce the complexity of the work. It will lead to more efficiency. And likewise, the one-piece move. If there are many components involved in the job, then the different components have to move, and they may be moving to different machines, and the opportunities for mistakes and for someone going missing is quite considerable. But also it's more handling, and there's more administration trying to keep account of everything, make sure everything is going to join up at the end to make the product. All the various components will come together and be assembled into the final product. The worry is that when it all comes together for assembly, there are going to be some parts overproduced or underproduced, or quality is an issue or whatever. So try to get it into one piece move if possible. Eliminate waste. Waste is anything which does not add to the value of the product. When the product's been produced, it's a value chain, and the value chain is what's going to make up the final product. Anything which is not involved in satisfying or producing the final product is a waste and should be cut. And try and produce in small lots. Small lots means less raw materials held on average. Less components are held. More of the materials are in production. Now, small lots have that advantage, but it means more frequent ordering and more frequent contact with suppliers. But that should not be an issue. If they're aware of the requirements, the JIT requirements and the scheduling, that should not be an issue. Use Kanbans. This is the Kanban system. This little card which simply has basic details, but it could be on a board which says orders received. And when it goes into work in progress, it just moves from one column into the next. Physically moves from one column into the next. And then it moves from the next column into finishing, and the next column into packaging and distribution. So we could have, depends on the complexity of the product, of course, we could have many columns, but in the example I've just given you, it just simply moves. The card physically moves from one column into the next as it moves through the production stage. So a manager looking at the board will know exactly how many jobs are currently in production, how many are in distribution, how many orders are waiting, and the Kanban system can flag this up. It can tell the manager as well the capacity of the business, how many can it cope with at any one time. It's the subject matter of separate videos, so I'd ask you to look at those. Make each operation produce a perfect part. Try and monitor quality right throughout the system. Try to involve the line operators and the line management in the quality procedures, just checking to make sure everything is right. There's nothing being produced that is not required or out of sync. There's nothing obvious going on. Because as soon as a machine is not working to the required tolerances, that machine should be closed down and fixed immediately, made right. Otherwise, the raw materials and the time, the labor, everything is wasted. All of that is dead money. So each operation should produce a perfect part. Smooth flows of production over a given time period. That's the essence of the level schedules. And it's trying to bring, in a sense of organization and a sense of positive achievement to everybody involved, because they know exactly what they're doing, and the level schedules means there's a smooth flow of production over that period, so everyone can subscribe to it. They know exactly what's happening. The schedules have been worked out precisely, so there's no need for worries about stopping machines and retooling and starting them up again and moving people around and clearing space and getting in new work and getting it set up. These are variations which are not good. So level schedules are important. Now, process frequent small batches rather than a few large batches. As I said earlier, there's a saving in raw materials and in storage, and it's more in keeping with the whole idea that if anything goes wrong, less is going to be lost as well. So there's more control in small situations with small batches. Make and move small lots so that level schedules is economic. So just use small lots, and the small lots are to particular tolerances and particular dimensions, so it's easier to have level schedules. In other words, there's no variation. The products are, in a sense, homogeneous within that run. They're all the same within that run, and the schedules can be worked out very precisely. Freezing the schedule closest to the due dates can improve performance. Once the due dates for the order are approaching, and if the schedules are working and have worked up to that point, if the various machines have worked according to the schedules and the operators found that they had time to make sure that everything was working smoothly at their end, the quality has been monitored and checked, and so everything had worked up to that point, then this idea of freezing the schedule, freezing it means gaining the knowledge of what happened. It's like taking a snapshot of the system, because the next time round when this happens, when an order of this nature happens, then it can be reproduced, and there's chances are it will run effectively. Now, I said earlier that Kanban is just touched Kanban. Kanban is the subject matter of separate videos, but I do want to just look ahead very briefly here as well, just give it a small run in this video. It's an important procedure. It's very simple, as I said, but it's very important. It's a Japanese word for card, and the card is an authorization for the next container of material to be produced. So imagine work contained in containers. Now, in the starting container we would have, let's say, some raw materials and a card, and the card would say process this into the following, and give a description, perhaps an order number, or it will give an order number, but it will also give a brief description of a part number that needs to be made out of the raw materials. So the operator knows exactly what to do. And when the operator has completed the task, those completed items will go into a bin, and the card as well. Now the card has completed that task, so it moves to the next task. So we can imagine a series of bins, physical bins, traveling along the production system. And also there's a Kanban board that may be in perhaps the manager's office. The manager knows exactly where the bin has got to and is able to move stickers on the board from one column, which says, let's say, move it from order into work in progress. So the physical sticker moves into work in progress. And later on it'll move from work in progress to dispatch or whatever. Depends on the nature of the product, how many different columns, different processes. So here we have a card, which is the authorization. Once the operator gets the Kanban card, the operator knows what to do, what to make, and there's the raw materials available, and there's the order that's been made. So everything in a sense is under control. Everything is so simple. A sequence of Kanbans pulls material through the process. So the Kanbans are in a sense being pulled through the process. They're being moved towards the final production because those are the instructions on the cards. The cards simply are telling each operator what to do. Here are the components, here's the card. The card says this is the job, this is when the order was received, now assemble these. And that's on the card. And in the office, at the same time, the manager will move the sticker from one particular process into assembly, because that's where the job has got to now. Many different sorts of signals are used, but the system is still called a Kanban. So it doesn't matter what the symbols are, it's still a Kanban. We can give an example of this graphically as follows. Let's say we have different containers, and these containers contain particular jobs, A241, K712, and so on. And these are part numbers. These are jobs that were completed in the past. They've made part numbers, and now we've got this list of part numbers. And then we've got a sticker on one of them. It's on one of the boxes, and it's on box A241. This particular sticker. The user removes a standard size container, so the user will now take away that container because that container has got the sticker. The signal is seen by the producing department as authorization to replenish it. So when the box has been emptied and returned as an empty box with a sticker on, then that's a signal that that box needs to be filled again. So let's say, for example, someone takes away box A241 and uses the various components in there, uses the various parts in the box. When it's traveled around the various parts it must go to, which are indicated on its Kanban card, so it can't get lost. So at the end there'll be nothing in the box, everything's been used up. And at that point the box is returned and a sticker is put onto the box. So now the personnel who are responsible for replenishing the stocks will see that box A241 is empty and that needs to be replaced. The stock needs to be replaced in the box. Very straightforward and very simple, and yet very effective. But as I said, it's dealt with in slightly more elaborate terms in other videos, and it's worth looking at those. But the idea of Kanban and Kanban cards is very important in the utilization of different techniques such as Jit and Lean production, because it's an efficient way of working. and it promotes these philosophies. Well, that concludes this session, so I'm going to leave it here and say thank you for watching this video.